Okay, so this is our first set of the new notes after spring break. Again, hopefully in class you heard me encourage you to really pay attention and watch these videos, because I'm telling you, what we're about to get into over the next week and to 2 weeks is one of the more difficult concepts that you will be dealing with probably in Algebra 1. I still have Algebra 2 students who struggle with this, but this does not exempt you from the fact that it will be on your EOC and whatnot. What we're going to be dealing with is factoring. Okay, today we're talking about monomials and factoring, but the most important thing is factoring. And what factoring is, it's very similar to dividing, especially when we start talking about factoring polynomials, binomials, trinomials, stuff like that. So let's just go ahead and jump right in. This is a very short page of notes, so just bear with me. You can print these out on Blackboard under week 5.3 resources. All right, so let's get started. First thing says to find the prime factors of the following numbers. Okay, well, prime factors are those factors which cannot be divided into again. For example, and this is also called factor tree. You guys have made factor trees before, but a prime factor is like a number like 1. 1 only has one number that divides into it. 1 times 1. 2. 1 times 2. Nothing else divides into 2 other than 1 and 2. Other than 1 and 2. 3. Nothing divides into 3 except for 1 and 3. 4 is not a prime factor because 2 times 2 goes into 4, as well as 1 times 4. So there's multiple factors of 4. So let's go ahead and we'll do our first tree. Now this is just a very small introduction. This is not a lot of what we're going to be doing the whole time. So factors of 12, you could do it a couple ways. Well, the first ones most people think of are 6 and 2. Okay. Well, what are factors of 6? Factors of 6 are 3 and 2. Well, is there any other factors of 2? Nope, just 2 and 1, so you just bring down that 2. So the prime factors of 12 are 3 times 2 times 2. 3 times 2 is 6, 6 times 2 is 12. But nothing else goes into 3, nothing else goes into 2, nothing goes into another 2. Another way we could have looked at this is we could have said, okay, I didn't start with 6 and 2, I started with 3 and 4, right? Well, nothing goes into 3, so bring it down, and 4 turns into 2 times 2. So your results don't change. Okay, the results don't change. You still have 3, 2, and 2. All right. Let's look at 210. Okay. Again, the first thing I think of is 21 times 10. And there's other ways to do this, but we're going to do it with what we can see first. We keep breaking down 21, we get 7 and 3. Break down 10, you get 2 and 5. So if I multiply 7 times 3 times 2 times 5, okay, I get 210. Can anything else go into 7? No. Can anything else go into 3? No. 2? No. And 5? No. So those are your prime factors. Okay. So we're going to take that and we're going to break it down even more. And we're going to use what we just learned. And we're going to add more to it. All right, so that's a big part of that. That's the foundation that we need in order to continue with our factoring. So let's go to the next thing. So now factor the monomials. Okay, again, remember a monomial. A monomial is one number. It could be a constant, like these are up here are monomials as well. Those are constants, but then again, a monomial is also the product of numbers or numbers and variables. So these are monomials, and the biggest thing that helps us remember these are monomials is the fact there's no plus or minus sign in between the terms. So there's one term. I know this looks like three terms. However, because they're all being multiplied together, once I figure out A and B, it's just going to be one term altogether. Okay? This whole thing makes up one term. This whole thing makes up one term. This whole thing makes up one term. So that's what makes that a monomial. Now, there's different ways to do this, and I'm going to show you what I think is the easiest way. Okay? But before I show you the way I think is the easiest way, this is the way that actually a lot of teachers, what they'll do first is they will expand this. And what I mean by expand this is they'll say, okay, factors of 15 are 3 and 5. So 3 times 5. And then they'll say, okay, times, how many A's do we have? A times A times A. How many B's do we have? Times B times B. Okay? So this is being factored right here. So you have a factor of 3, a factor of 5, a factor of A, a factor of B. However, okay, we do not do this a whole lot in Algebra 1 or 2. So when we actually factor something, we're taking out something that they have in common. Okay? For example, no, excuse me, that's how I want to do this one. Okay, so let's do this here. Let's factor, and again, factoring this is just showing me what the factors are. Okay, so show me what the factors of this monomial is. Well, you take out a negative 45, what do you get? You get a negative, how about 9 times 5? Okay, and then you have times x times y times y. Continue to break this down. You have negative 3 times 3. Bring down your 5. Does it have anything else that goes with it? No. So you have negative 3 times 5 times x times y times y. Now there's one other thing that you do here when you have a negative. When you have a negative, you got to take that negative 1 out. So negative 3 is actually negative 1 times 3 times 3 times 5 times x times y times y. So here are our factors of this monomial. Here, we can do 7. So here's 7 times R times R times S times S times S times S times S times T. Okay? And that's pretty much it. And of course, 1 is always a factor of all of these. Okay, now again, you're not going to do this a whole lot. What this does is helps you understand what the factors are. What did I need to multiply together, okay, in order to get this monomial? In order to get this monomial, I multiplied all these together. In order to get this monomial, I multiplied all these together. Okay, same thing up here. In order to get 12, I multiplied all these together. In order to get 12 here, I multiplied these together. Same numbers. In order to get 210. If you go all the way down to the prime factors, they're always going to be the same no matter which direction or which route you take. Okay? All right. Now, here's where we really get into the stuff that we do more frequently. It says the greatest common factor. The greatest common factor, that's what this blank is right here, we call this the GCF. You've heard this before, I'm sure. Of 2 or more integers is the product of the factors common to the integer. Product of the factors common to the integers. Okay, so let's take a look at what that means. So on the next one, we're going to find the GCF of 15 and 35. So what factors do they have in common? There's a couple ways to do this too. You could go by the factor tree. We could do 3 and 5. Doesn't go any further. And then here you do 7 and 5. Doesn't go any further. So in this case, what do they have in common? What do both numbers have? They both have a 5. So the GCF is 5. Okay. The other way you can do this is make a table, and this doesn't really work out too well with this one just because they're prime already. So 3 and 5. Okay. Then you have -3 and -5, right? And then 35. You have 5 and 7, or -5 and -7. Okay, that's another way to do it as well. Whichever one makes you most comfortable is fine. However, again, a lot of this is just an introduction. We're not going to do this a whole lot throughout the rest of this week. We're going to do it tomorrow a little bit, but after that, a lot of this GCF, finding the GCF, is something that you need to be able to do in your head. For example, if I look at 12, 42, and 96, okay, let's think about this. Without doing this on paper, what do you think the greatest common factor is? Well, let's start with the highest factor of 12 that you can think of. The highest factor of 12 is 12. Does 12 go into 42? No, because 12 times 3 is 36. 12 times 4 is 48, so it doesn't hit 42. So we got to go back to 12. What's the next highest factor of 12? 6. Okay. Does 6 go into 42? Yeah, 6 times 7 is 42. Does 6 go into 96? Okay. Well, 6 goes into 96. 1. That if you do 96 divided by 6, you have 1, which is 6. Bring down the 3, which is 36. 6 goes into 36 16 times. So 6 times 16 is 96, right? So 6 goes into 12, 6 goes into 42, and 6 goes into 92. Now here's the deal. I know some of you are saying, well, there's higher factors of 96. Okay? However, does that higher factor of 96 go into 12? For example, 16 is a factor of 96. Does 16 go into 12? No, there's no way you can multiply anything by 16 to get 12. So you got to start with that smallest number and find the smallest number, and find the highest factor of that one that will go into all three. And in this case, it's 6. So your GCF is equal to 6. Okay, and that was done mentally. Okay? Now let's look at some monomials. Let's find the greatest common factors of the monomials. Again, start trying to do this mentally. This is my smallest one. What are the factors of 3 and 15? I'm sorry, 15. Factors of 3 and 15 are 3 and 5. Okay, does 3 go into 27? Yes. Does 5? Okay, 5 is the higher of the two. Does 5 go into 27? No, it doesn't. Okay, so my greatest common factor right now is 3. Okay, so I took care of the big numbers. Now, do they have an A in common? Yes. How many A's do they have in common? Well, this one only has one A, and this one has 2 A's. So all you can say is they have a greatest common factor of 1A, because this one doesn't have 2 of them. Okay? So in this case, you take out the smallest amount that you can take out. So I could take out A. And then B. So A's are done. Okay, B and B squared. Do they have B in common? Yes, they do. How many B's do they have in common? This side only has one B, but this side has 2. So they can only take away 1. So you just put B over here. Okay, so B is done. Now, do they have C in common? No, C is only here. They do not have that in common, so that is not going to be part of your greatest common factor. So your greatest common factor is 3AB. when we start factoring, this is going to be important because when you start factoring, what's going to happen is you're going to take those greatest common factors out. So if I take out a 3, this becomes 9. And if I take out an A, it becomes 9A. And I take out a B, the B goes away. So then my greatest common factor out of there is 9A. So if I multiply 3AB times 9A, do I get 27AB? 27A squared B? I do. If I take the greatest common factor out of here, which is 3AB, and I stick it right here, well, taking 3 from 15 gives me 5. A divided by A is nothing. That's gone. B squared divided by B is just 1B. And then C has got to stay in there because I didn't take it out. So now here's your greatest common factor out here. If I multiply this times this, will it give me this? So 3 times 9 is 27. A times A is A squared. B, okay, just comes in. That's B. 3 times 5 is 15. A times A is, A times A just goes up. Sorry, B times B is B squared. And then C just goes up. So that's what we're really going to be doing later on. Okay, let's go in here again. What's the greatest common factor here? Well, you know at least -1 comes out because that negative's got to go out. Okay, so let's think about this. What goes into 39 and 26? Start with 26. What's the greatest common factor of 26? Well, at first you start with -26. -26 does not go into 39. So then your next highest factor would be -13. Okay, -13 goes into 26 2 times. -13 goes into -39 3 times. So -13 is the greatest common factor. So I'm going to start with GCF is equal to -13. Then, do they share x's in common? So the big numbers are done. They have x in common? How many? This one has 2, this one has 1. The only thing they can share is 1x. So x comes out, that's done. Now here, do they have y's in common? They do. How many? This one has 3, this one has 4. Well, if it has 4, then it has to have 3. So I can take out how many y's? 3 now, because they have 3 of them in common. Okay? So our greatest common factor is -13xy cubed. If this is complicated or you're confused, you need to make sure you get help in tutoring because it's the easiest part. So if you have any questions, write the questions down and bring it to tutoring tomorrow morning. And then finally, our last example says the sides of a triangle are 12wz squared, 8wz, and 16w squared z. This is find the greatest common factor of these 3 sides. Same thing. We're doing up here. This time we have 3 different sides we're pulling from. Start with the smallest number. What's the greatest common factor of the smallest number? Well, the greatest factor of the smallest number is 8, right? Does 8 go into 16? Yes. But does 8 go into 12? No. There's nothing times 8 that will make 12. So go down. What's our next highest factor for 8? It's 4. Okay. Does 4 go into 16? Yes. Does 4 go into 12? So 4 goes into all of these. So our GCF starts off with 4. Okay. Do they all have a W? So that's done. They have a W. 1 there, 1 there, 2 there. Well, the slowest amount of W's they have is 1, so bring down 1 W. Do they all have a Z? 2 here. We're done with the W's. 1 here, 1 here. So the lowest amount of Z's they have is 1, but they all have 1. The lowest amount of Z's they have is 1, so bring down 1 Z here. So our greatest common factor is 4WZ. And again, anytime you want to check your work, okay, just take this and multiply by what's left. And we'll talk more about that later. So again, here, let me look back here real quick, because I was saying it here, I want you to understand this. When I look at this y here, what I'm going to do is I'm going to take down the smallest one. Maybe that's easier than saying they both share 3. They both do share 3, but take down the smallest of the 2 y's. So y3, y4, the smallest of the y's is y3, so that's why you bring it down. Here we had the smallest of the W's was 1 W, smallest of the Z's was 1 Z, so that's why I brought those down. Okay, again, factoring is complicated, somewhat confusing. This is going to be one of the most difficult lessons that we will do all year. Please make sure you ask any questions that you have, write them down, and bring them to tutoring on tomorrow morning. If you have any questions, I will be glad to answer those again in tutoring, but you need to make sure you take these notes and be prepared for class tomorrow. All right, have a good one.